some answer to this question of whether or not we're alone in the next couple of decades.
Yeah, and then the side bet, of course, is SETI. So
Yeah.
in parallel to these very well motivated research programs to find Earth-like planets where we're just marching down in sensitivity towards Earth's, and we know we'll get there, and where the techniques to diagnose the atmospheres are completely understood, and it's just a hard technical problem to get the data. SETI is sort of, as a sort of shot in the dark. You don't know whether and when it will succeed. And the SETI people don't like to be left on the side of all this excitement because, of course, they're dealing with 50 years celebrating an anniversary of what they call the Great Silence, which is they've been listening for radio signals and they've heard nothing. But they're not losing hope at all. They're as excited as the planet hunters because they say that the Moore's law and the computational capabilities they have mean that the search is getting exponentially better, almost at the level where each new year of searching you search as much parameter space as you searched in the entire 50 years before. So Jill Tarter's analogy of this was that, the ocean of potential intelligent life is like an ocean. And until a few years ago, they'd just taken a cup of water out of that ocean and said, no, there's no intelligent life in that cup. And now they're going to start to trawl large volumes of that water to see if there are intelligent communicating creatures there. And so they're very excited too. Now they can't be as confident as the planet hunters that they will find what they're looking for in the 10 years, 20 years, or 30 years. They might indeed fail. They might never find something. But they would say that the search is only now getting interesting, what they're doing.
Have you gotten any impressions about the challenges that this field faces and like what is really holding the field back, if anything?
Yes, they were. I asked this explicitly sometimes, and I have been to enough conferences and just talked to people to learn enough about that. It's ironic because I alluded to the interdisciplinarity as one of the exciting things that motivates the individuals, and it makes the conferences incredible. I love those conferences because you learn so much. You learn geology and biology, and it's enervating to learn that. There's a flip side to that, though, which is as you know, science is still very it's very channeled, it's very siloed. So people build their reputations, they get their academic jobs, they get the big prizes in their profession by being experts on kind of narrow little subtopics or niches. So there's actually a pressure against being interdisciplinary or broad if you want to succeed in your profession. And that's a tension that they haven't really resolved in astrobiology. Most of the people in the field are just optimistic enough, and they're sort of just willing to accept that it actually may not be in their best interest professionally to do this work. That's one problem. And another problem is, which is a little bit related, is the funding is not dramatic in astrobiology. NASA has been one of the largest supporters of astrobiology in this country. NSF, the National Science Foundation, puts almost nothing into it. Around the world, there are little pockets of astrobiology, but it's a pretty small field. I would say the total funding in the U.S. for astrobiology is maybe $100 to $120 million a year, and that's a very small fraction of the scientific pie. So it's not really well funded. Now, if you've put planetary science and space missions in the solar system in the mix, of course, there's a lot of money in there. But if you're talking about looking for life, it's a pretty small, niche-y field. And they feel a little bit held back by that.
On a side note, coming from talking about life and where we're going to find it, how we're going to be looking for it, previously in 2010, you published a book, How It Ends. And I was doing some reading online, and I found it interesting that your experience as an astrophysicist looking at the expansion of the universe and how the thinking about what's going to happen to the universe led to writing a book about how everything from human life to one human life to a species life to the world to the universe ending. Can you just talk about that book very briefly?
Sure. I actually was preferring to write a book on cosmology more about beginnings than endings, but I think I'll get to beginnings in the next book. Right. Endings was intriguing to me because it was the challenge of talking about everything from human disease and how we die to the end of the universe in one framework, which I like because I get to learn a lot of stuff because I was talking about fields I wasn't that familiar with. And I guess the secondary challenge was to talk about this without it being a huge downer. I mean, I didn't want to have to, shrink wrap antidepressants in the sleeve of the book because it was so gloomy. So I tried to write it in a tone that was, of course, a little tongue-in-cheek, a little lighter. And as far as connecting it to what we're talking about, what I did, I mean, the take-home message, if you like, was that life, biology, even as we know it, forget about the forms we don't understand, is going to have a really long run in this universe. So to give you one example, in about a few 100 billion years or a trillion years, the Milky Way is going to go dark. All the stars that are out there will have died, and so in some view, this is horrible, because we depend on the light of our sun, and if the stars all go out one by one and turn into husks, neutron stars, black holes, white dwarfs, and the universe goes dark or are part of it, that sounds horribly bleak and depressing, but part of the lesson of extremophiles and life on Earth is that you don't need a star. You can get emotionally attached to a star, and you could put an artificial star in your sky, but all life really needs is energy. And even in this distant universe ahead of us, a trillion years from now, when the Milky Way has essentially died, there's tons of energy available, gravitational energy, basically, the gravity of all these collapsed objects. And any intelligent civilization, we're not far from being able to do it ourselves, could easily tap that energy to fulfill their hopes and dreams for trillions of years more. So one of the things I realized in writing that book was that some of these, crazy long timescale and seemingly bleak endings of larger regions of space than our own didn't actually imply that the party had to end.
It's good to know that we don't, wrong image. It's good to know that we don't necessarily, that it doesn't have to end, that there could be more to it. It's nice, it's good to think about the positive implications of an end, I guess. Well, we're at the end of our hour, and I just want to say thank you very much, Dr. Impey, for joining me today on the show, for talking about all these just fascinating questions, the question of life on Earth, life in the universe, and the main questions of how long is this going to be here? What are we going to find? Are we going to get off this rock? What are we going to find when we do? It's just been a fascinating hour, so I really appreciate your time.
Okay, thank you. I appreciate it. I've enjoyed it.
Thanks. And for everyone out there who's interested in this topic a little bit more, Chris Impey has his own website that you can go to for more information. Oops. For more information, you can go to Chris Impey, ChrisImpey.com. Additionally, his other books are The Living Cosmos, which you can find online, thelivingcosmos.com. How It Ends is also available online, thebookofendings.com, if you're interested in that. That is also, I think there's a link to being able to buy that online. And the book that we started out talking about this hour, Talking About Life, is available on Amazon.com if you're interested. Talking About Life, Conversations on Astrobiology, which is, I think, just a great survey of what different experts in the field think about this topic. We have people from journalists like Timothy Ferris to Neil deGrasse Tyson, scientists, and all sorts of people. Chris McKay, Carolyn Porco, Seth Shostak, Jill Tarter from SETI, Ray Kurzweil, futurists, as Dr. Impey mentioned previously. Some really great conversations that would probably be fascinating to take a look at if you're interested in that as well. And that is the end of another episode of Dr. Kiki's Science Hour. If you are interested in more of the Science Hour, you can download previous episodes by going to twit.tv/Kiki. That's twit.tv/KIKI. You can download directly from the website, or you can subscribe to the podcast as either an audio or a video program. Your choice. Take your pick. It's pretty exciting. We're also available on YouTube, so you can go to YouTube and catch up on these episodes if you've missed them and you'd like to take a look. Next week, we're going to be talking about science hacks and robots. So we're going to be talking with a group of people who've been hacking the science to create robots that might be headed to Mars one day. So stay tuned for more programming on the Twit Network. Come back next week. Join me again for more science with the Science Hour. I really appreciate your time today, and I do hope that, if nothing else, this hour of programming made your life a whole lot more interesting.